Hi guys, today we're going to do lesson 31-1, solving by graphing or factoring. Our learning targets, we're going to use a graph to solve a quadratic equation. We're going to use factoring to solve a quadratic equation and describe the connection between the zeros of a quadratic function and the x-intercepts of the function's graph. Carter, Alicia, and Joseph are building a trebuchet for an engineering competition. Yeah, that's a trebuchet, not a tree bucket. A trebuchet is a medieval siege weapon that uses gravity to launch an object through the air. When the counterweight at one end of the throwing arm drops, the other end raises and the projectile is launched to the air. The path the projectile takes through the air is modeled by a parabola. See, it's going to go through here. It's going to take the path of a parabola. There we go. To win the competition, the team must build a trebuchet according to the competition specifications and to launch a small projectile as far as possible. After conducting experiments that varied the projectile's mass and launch angle, the team discovered that the ball they were launching followed a path given by the aquatic equation y equals -1/8 x squared plus 2x. And then we have the graph of that. Okay, make sense of the problem. How far does the ball land from the launching point? So let's kind of look at the information that we have on the graph. And remember, this is the distance down here. So your x values are distance and our y values are height. So obviously, when we get ready to shoot the projectile, it's at 0, 0. So it's on the ground, and we're about ready to shoot it out, and then it's going to go ahead and go. It's going to fly through the air, and then when it gets back down to the ground, that distance from the ground is the distance traveled. Okay, so that's going to be this distance right here. And then, of course, is going to be 16 meters. 16 meters. All right, item 2 says, what is the maximum height of the ball? So again, we're looking through here. The maximum height, remember your maximum is your y value, which is our height. And we just look for the highest point. So that's going to be somewhere up here, probably right around 8. Okay, so 8 as far as the distance from the launching point, and that's going to be at 8 meters high. 8 meters high. Okay. Now that makes sense that the vertex is going to be at the height. So remember, we have our line of symmetry going through the vertex, and you notice we have 8 this way and 8 this way, and this is going to be symmetric. All right, so item 3, what are the x-coordinates of the point where the ball is on the ground? So obviously it's going to be on the ground at 0, 0. That's going to be one of the points. 0, 0. And what's the other point going to be? Well, on the ground means that the y value is going to be 0. And the x value is going to be how far it travels. That's going to be the 16. So 16, 0. To determine how far the ball lands from the launching point, you can solve the equation -1/8 x squared plus 2x equals 0, because the height of h equals 0. So we're going to verify that x equals 0 and x equals 16 are solutions to this problem. Now, remember, we're going to verify that by simply plugging in. So we have -1/8 times 0 squared plus 2 times 0 equals 0. And that makes sense because 0 times anything is 0. All right, 0 equals 0. So that's fine. So that verifies that x equals 0 work. Now the x equals 16, that's going to be -1/8 times 16 squared. Okay. and plus 2 times 16, and that's going to equal to 0. And basically what you're going to do is you're just going to verify that's what's going to happen here. And so if we use our calculator here, so it's going to be 16 squared times 0.125, and it's going to be a negative 32. So that's going to be negative 32. It's going to be a plus 32. And of course, those cancel to become 0 equals 0. Okay. So we've verified that those are both correct. It says, without the graph, could you have determined these solutions? And you know, obviously, if I can calculate these here, if I can figure out what the values would be of x that will make this a true statement, then I could certainly do that without a graph. The factored form of a polynomial equation provides an effective way to determine the values of x that make an equation equal to 0. Now, what do we mean by that? Well, let's go ahead and look at the example. Example A. Solve negative 1 over 8 times x squared plus 2x equals 0. First thing we want to do is factor out the x. It's going to leave me with negative 1 over 8x plus 2 equals 0. Now I have two factors that are equal to 0. Now, what we have to think about is, how can I make this whole thing equal to 0? Well, if this x is equal to 0, then 0 times whatever that is in the parentheses will be equal to 0. So that's how I know that x equals 0 is one of the solutions. The other opportunity, though, is if whatever's in this parentheses is equal to 0, then the whole thing will be equal to 0. So I'm going to set this negative 1/8x plus 2 equals 0. And when I do that, I solve for x, and so I have to get rid of the plus 2. So I have negative 1 over 8x is equal to negative 2. And then I want to get x by itself, so I'm going to multiply this by its reciprocal. So it's going to be negative 8 over 1. Negative 8 over 1. And so these all cancel out. That leaves me with x is equal to 16. So that tells me the solutions of this quadratic equation is 0 and also 16. Let's go ahead and do a try these. Try these A. Solve each quadratic equation by factoring. X squared minus 5x minus 14 equals 0. X squared minus 5x minus 14 equals 0. And I want to go ahead and first of all factor these. So I'm going to have two binomials. Each one's going to start off with x, because x times x is x squared. The back sign tells me the signs are going to be different. Front sign tells me the largest factor is going to be negative. I'm looking for factors of 14 that, when you subtract them, you get 5. So that's, of course, going to be 7 and 2, because 7 minus 2 is 5. And the 7 needs to be the negative. Okay, so now in order for this whole thing to be equal to 0, either this first binomial or the second binomial must be equal to 0. So I just set each one equal to 0. So x plus 2 is equal to 0. When I solve for x, subtract 2 from both sides, x is equal to negative 2. So when x is equal to negative 2, this binomial will be a 0. 0 times whatever the other binomial comes out to be, the total is going to be 0. So now we set the other one equal to 0. X minus 7 equals 0. Add 7 to both sides. X is equal to 7. So again, if I plug in a 7 for x, then this one's going to be a 0. And 0 times whatever that is going to be 0. So the answers on here is x is -2 and x is equal to 7. Item B, 3x squared minus 6 equals 0, and 6x equals 0. So I want to factor these. First thing I look for is the greatest common factor. Looks like the greatest common factor in this one is 3x. So 3x squared divided by 3x is x, and then -6x divided by 3x is just 2, -2. And so in order to make 3 times x equals 0, then x has to be 0. So one of my solutions is x equals 0. That takes care of that one. If I want to make this one 0, it's going to be x minus 2 equals 0. Add 2 to both sides. X is equal to 2. So my solutions are x equals 0, x is equal to 2. Item C. Item C is x squared plus 3x equals 18. Now, if you noticed, we're wanting these all to be set equal to 0. Well, this one is set equal to 18. I need to get a 0 on this side. So in order to get 18 to become 0, I just subtract 18 from both sides. So I end up with x squared plus 3x minus 18 equals 0. And now I can go ahead and factor. So it's going to be x times x, which is x squared. The back sign tells me their signs are different. Front sign's a positive. That tells me the larger factor is positive. And I'm looking for factors of 18 that when I subtract them, I get 3. And so the factors of 18 that fit that rule are going to be 6 and 3. And my larger number has to be the positive, so the 6 is going to go with the plus sign, and the 3 is going to go with the minus sign. So now I want to make each one of these binomials equal to 0 to find out my two solutions. X plus 6 equals 0. Subtract 6 from both sides, so x is equal to -6. And the other one is x minus 3 equals 0. So I'm going to add 3 to both sides. So that means x equals 3. So my solutions for that one is x equals -6 and x is equal to 3. Item 6. How do the solutions to the projectile path equation -1/8 x squared plus 2x equals 0 in example A relate to the graph? Remember, the solutions are the x-intercepts. In other words, the x value where y is equal to 0. The graph of the function y equals x squared plus or minus 6x plus 5 is shown below. Identify the x-intercepts of the graph. So as we look at the graph, we notice where the x-intercepts are. They're where they cross the x-axis, or where y is equal to 0. And so that's at x equals 1 and x is equal to 5. So what is the x-coordinate of the vertex? Well, your vertex, of course, is your minimum or your maximum. And so the x value of that is going to be 3 in this case. And again, it's important to notice that your solutions, or your x-intercepts, are going to be equal distance from that line of symmetry. In this case, it's 2 over here, 2 over here. Describe the x-coordinate of the vertex with respect to the two intercepts. And like I said, it's halfway between the two x-intercepts because the x-intercepts are equal distance in either direction from the line of symmetry. Item number 10. Factor the quadratic expression x squared minus 6x plus 5. So we're going to go ahead and factor that. It's going to be x squared minus 6x plus 5. And we'll go ahead and we'll try to factor this. It starts off with both binomials being an x, because x times x is x squared. The second sign tells me that both of them are the same. The first sign tells me they're both negative. I'm looking for factors of 5 when you add them to get 6. So that's obviously going to be 5 and 1. And it doesn't matter where we put them, because the signs are the same. So now we have that factor. 10b. Each of the factors you found in part A is a linear expression. Solve the related linear equation for each factor by setting it equal to 0. So again, it's going to be x minus 5 equals 0, and x minus 1 equals 0. And of course, we're going to solve this. We're going to add 5 to both sides. It's going to be x is equal to 5. And we're going to add 1 to both sides. It's going to be x is equal to 1. C, solve the related quadratic equation for the expression in part A. That is, solve x squared minus 6x plus 5 equals 0. So, in a sense, we're basically just doing the same thing. So we're going to end up with x is equal to 5 and x is equal to 1. We want to test them just to make sure. So we have our 5 squared minus 6 times 5 plus 5 equals 0. So that's going to be 25 minus 30 plus 5 equals 0. 25 minus 30 is negative 5 plus 5. And negative 5 plus 5 is equal to 0. So we verified that the 5 is a solution to this quadratic. And now we want to verify x equals 1 is a solution. So it's going to be 1 squared minus 6 times 1 plus 5 equals 0. 1 squared, of course, is 1. 6 times 1 is 6. So 1 minus 6 is negative 5 plus 5. And negative 5 plus 5 equals 0. And again, we've confirmed that x equals 1 is a solution to the quadratic. Item 11. How do the linear factors of x squared minus 6x plus 5 you found in item 10a relate to the x-intercepts of the graph of the function y equals x squared minus 6x plus 5 shown above? Well, they're the same. 11b, without graphing, how could you determine the x-intercepts of the graph of the quadratic function y equals x squared plus x minus 12? So the way we would do that, of course, is we would set the quadratic equation equal to 0 and then factor the quadratic expression. The x-coordinates of the x-intercepts of the quadratic function y equals ax squared plus bx plus c are called the zeros of the function. The solutions of the quadratic equation a times x squared plus bx plus c equals 0 are the roots of the equation. Essentially, the terms y-intercept, the term zeros of a function, the term roots of a function, and the term solutions of a quadratic equation all represent the same value, and those are the x-intercepts. Item 12. The quadratic function y equals ax squared plus bx plus c is related to the equation ax squared plus bx plus c equals 0 by letting y equals 0. Why do you think the x-coordinates of the x-intercept are called zeros of the function? Well, the reason why they're called zeros of the function primarily is because their y value is equal to 0. 12b. Describe the relationship between the real roots of a quadratic equation and the zeros of the related quadratic function. And again, they're going to be the same. The real roots of the quadratic equation and the zeros of the related quadratic function are the same. We call it roots when we're talking about the quadratic as an equation. We call it zeros when we talk about the quadratic as a function. Check your understanding. I'm going to leave the check your understanding as well as the practice problems for you to do as homework. Again, if you have any questions, you're certainly welcome to come to the tutoring session on 3 o'clock on weekdays, and be happy to answer any questions. That being said, we're finished. Thank you.